Microphone check test one. No, I'm joking. Sorry. All right, we're finding the implicit differentiation of the following. So our goal is to get dy dx all by itself. So we're going to start deriving now. So constant multiple rule this 7 out, and we're just going to concentrate on doing the exponential rule of differentiation for what you see, which is the carbon copy times the natural log of the base, which will become 1. Not always the base is like 2 or 5 or whatever, but times the derivative of the power, which in this case would be the product rule. First times the derivative of the second, plus the second times the derivative of the first. Remember, we are in respect to x, and if it didn't say that, that is the default. That is the understood default. That means when you multiply by the derivative of x, that's where that 1 would appear right here. All right, so looking at this, we have all this was the derivative. This is a form of 1, so we have e to the xy times the parenthetic piece of the following with parentheses. And then we're going to add 6x minus 6y chain rule dy dx, and then it's equal to 0. And my goal is to get now dy all by itself, or dy dx. We good? Okay. What am I concentrating on right now? All these pieces laid out, what do I gravitate immediately to start organizing stuff? Okay, factoring out dy dx, but even before that, those of us who struggle a little bit more, is I'm looking at all of these addition and subtraction pieces. I didn't see this, I didn't highlight this as gray because of the fact that I am going to have to distribute this so that I could GCF my dy dx at the end. Okay? So when you see two dy dx's like this, if they were already outside of a parenthetic multiplicative piece, yeah, you just combine like terms, be done with it. But because of this, I have two dy dx's. The strategy is to distribute this first and then GCF later. Okay, here we go. So we have 7 e to the xy times x dy dx plus 7 e to the xy times y plus 6x minus 6y dy dx is equal to 0. Now, the islands, if you will, that are separated with addition and subtraction become a little bit more obvious. My goal is to move everything that does not have a dy dx to the opposite side. So I will end up getting, this 0 will change to a negative 7e to the xy times y minus 6x, and I'm going to end up dividing by whatever's left over here after I GCF out the dy dx. So let's see what we get. This right here is left on the left side, and this is on the left side. And if I were to GCF out a dy dx, what's left over would be 7e to the xy times x minus 6y, because those are those coefficients that we're multiplying with the dy dx pieces that you see. And then just divide this over by making it into the denominator, and there's your answer. It is Webassign. Do you have to simplify with Webassign? No. So you don't have to get this exact answer exactly written like that. It still can be equivalent and correct. Yes?
In my numerator, there was an addition sign instead of a subtraction sign in between the first and second term.
That's okay. So, like right here, what they did is they could cancel or GCF out a negative so that they would have an addition like this. And let's say at the very bottom, they also did that negative, okay? So look, let me go ahead and move this down so that you can see the rest of this worked out. If we were to move this over here as 7e to the xy x minus 6y, we could also GCF out a negative. This is one of the biggest prevalent algebraic manipulations to multiple choice answers. They will pull out a negative. Let me show you. Like on the bottom, if I factored out a negative, that would change this to a positive, and then those cancel to a form of positive 1. So that this could also be written as the correct answer.
Can it be done with just a positive on top? Or like just the negative with the plus and then the negative sign left in the bottom one?
As long as you can GCF out a negative, it's still going to be equivalent.
Okay.
But you'll want to do it from both top and bottom. Okay. All right. Any other questions? Okay.